Hello ladies, in this video we're going to go through the difficult questions in 5H, which is a volume of a cylinder. Now I have chosen question 11 in particular because we're not really dealing with a full cylinder, we're dealing with a part of a cylinder. So you can kind of see here we've got a bunch of shapes. They all look a little bit different. I kind of look at this one and see a piece of cake. This one may be a bigger piece of cake. This one here, another piece of cake. Here it's like a skateboard ramp, aren't they? And then this one here, you've kind of got a rectangular prism and then a sector on top of it. So you've got the sector formula here. So when we did sectors back earlier on in chapter 5, theta is just the angle. Okay, so you're just, and theta over 360 just tells you what fraction of the circle you're taking. And then the pi r squared is the area of the circle. Now, each circular part is a constant cross section. So you can kind of think of this part here, this part on top, which I might actually start shading because I know that I can draw on my diagrams. Just give me 1 second. So I'm going to highlight the constant cross section. So there it is there. Constant cross section for this bit is this bit here. Now you could actually slice, I was going to say your cake along this way, and you'd actually have a constant cross section that way as well. And that's usually how we do cut cakes. Okay, so your constant cross section would be that rectangular shape, but it's a lot easier, I think, to do your area of your sector and then multiply that. Okay, and we've got this constant cross section here. Now, when we get to D, your constant cross section is going to be this part here. Now, can't color in within the lines. So that part there, when you think, is not a sector, but we're going to be using our knowledge of circles to actually work out what that area is. And then a similar part is going to apply here. And then our last question, can't color in too well, our constant cross section is going to be the rectangular part on the bottom and then the sector on the top. Okay, so in this video, we're just going to cover those 6 questions. All right, so let's get started. Okay, so question 1, actually what I'm going to do is just do a page break so I've got enough space. I don't have to do the page break later. Okay, so question A, bear with me. Okay, so our sector, so the top part, and I'm just going to do the area of that. So it's theta over 360 times pi r squared. Okay, so that's that area there. It's a terrible drawing of a sector. And then we're going to multiply that through by this height. Okay, which is 8. Okay, so I'll write that in a sec. All right, so theta is 45 over 360. Pi, your radius is 6. Did I write 8 before? Times 6 squared, and your length is 8. So put all that into your calculator. I might just press pause while I do that. All right, so our answer is 113, sorry, 0.973, blah, 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 blah. We have to do it to 2 decimal places, so our cutoff point is here. So we look at this point for our rounding. So we are going to round up. So that 9, we increase that, then this 10th position by 1. So it's going to be 113.10, and we're working in centimeters cubed. All right, question B is very similar. Okay, you're just going to have 120 for theta, and your radius is 20 and your height is 25. So I might just do the formula over here, but I'm not going to do all the calculations because I want to keep these videos quite short. Okay, so your area is 120 over 360 times pi. The radius is 20, so times 20 squared, and then times the height of your cake is 25. And then just plug that all into the calculator. Question C is also quite similar, so I'm just going to write the formula for that. So we've got 60 over 360 times pi times your radius, which is 1.8. Now you do need to get your radius correct, and 2.2 for the height of your cake. All right, so D, E, and F are slightly different. All right, with those other ones, I might actually go back up to our diagram to show you, because I'm going to probably have a bit of trouble drawing this. Now, with this constant cross-section, if I go across like that and just draw a square, so think of this as just the 2D shape, what I now have is a sector, okay? So I'm just going over that there. So there is your sector. Maybe I'll color that in a different color. Do that in purple. So if we work out this purple part, which is sorry, I know if I try to undo that, it's just not going to work. So that purple section, your sector, and then this green section, you can just take away that sector from that square that I've drawn. So I'm going to redraw that part. Okay, so think of that like if we were to make a skateboard ramp, we would start off with maybe a wooden piece of wood, a block of wood, and we're going to take away that part. It did say that that is a right angle triangle, so this is also a right angle triangle, and we've got 4 here, and this is 4. So we're just looking at the front part. Remember, I shaded in before this sector, which is just purple. So let's have a look at doing that part first. So the area of a sector is theta over 360 minus pi r squared. Oops, not minus, sorry, times pi r squared. So theta is 90 over 360 times pi. Now the radius is 4, okay, because it's a square, so the radius is 4, so times 4 squared. And then we'll just do that on, actually I'm not going to do that on the calculator, I might just leave it as that for now. Now the other section was this green, so the constant cross section, which I'm going to colour in green again. Okay, so it's not a triangle. I know I said triangle before, but I'm used to, in year 11 at the moment, we're doing triangles or trigonometry. Okay, so that whole square, I need to take the area of, so it's going to be 4 squared, which is 16. So we've got 16 minus all this times pi times 4 squared, which is 16, but I'm just going to leave it like that. Okay, so that's your the area of the green, or your constant cross section. I'm just going to do that on the calculator. So 16 minus 90 over 360 times pi times 4 squared. Okay, so I get 3.4336, blah, 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 blah. Now, I haven't finished. I've just found that constant cross section. So remember, we need to multiply it by the length. So your volume, what was the length again? It was 6. So 6 times 3.4336. If you leave that in your calculator, it's probably best to then go times 6. And our answer is 2 decimal places. So I get 20.6017, blah, blah, blah. And that's going to round to just 20.6 0.60, and we're working in centimeters cubed. All right, I'm just going to check my answer. Beautiful. It's always nice when you get it right. Okay, question E. So I might scroll back up so you can see. So this time here, we've got like a half pipe. So I've got my diagram here. The radius of that circle is 10. Okay, so this side is 10, this is also 10, and then 10 and 10. Okay, so I'm going to find the area of this purple section. Okay, so it's just half a circle. And then do the same working out. Okay, so let's go back down. I'm going to draw just that front part again. Whoops. You get the gist. Probably that should have reached the bottom. Okay, let's colour in. And then we've got that green section. Okay, so the area of that sector, or it's just basically a half circle. So you can do half times pi r squared. Now your radius, what was it, 10 from memory? So half times pi times 10 squared. Then the area of that whole rectangle is 10 times, oh gosh, my writing, sorry, it should be a 10 times 20. So the area of the green, or your constant cross section, is the area of that rectangle, so 10 times 20, minus the area of this purple section, so your half circle. All right, so then just do that on the calculator. Minus half times pi times 10 squared. So I get 42.9203 blah, 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 blah. And we want to multiply it by the length, which is 20. So the total surface area, oh, sorry, not total surface area, your volume is 20 times 42.92036, blah, 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 blah. So I'm just going to multiply my answer on my calculator by 20. So I get 858. And then how many decimal places? 0.41. All right, let me just, I always check the answers. Don't want to make a mistake. Beautiful. We need our units, so centimeters cubed. All right, the final question. Actually, let's have a look at it up here. So if you do each part separately, so if we treat, we've got basically a rectangular prism with a slice of cake on top, or a slice of cheese, whatever you want to call it. So you can work out both of them separately. So I'm going to scroll down. So do the volume of the rectangular prism, which is length times width times height, plus the sector. So we had theta over 360 times pi r squared. Okay, so let's just plug that all in. And then, sorry, and then that's, oh, just bear with me. I'm just trying to figure out what the length of the shape is. 7 times length. Okay, so we've got 8 times 7 times 4. So that's the rectangular part. And then the sector on top. Your radius is 8. And the length of that cheese is a little bit hard to see, but is 7. Okay, so plug that all into your calculator. So 8 times 7 times 4 plus 30 over 360 times pi times 8 squared times 7. Beautiful. And we get 341.2861, blah, 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 blah. We're doing it to 2 decimal places, so we cut it there. We look at that digit, so we're going to be rounding up. So 0.29 centimeters cubed. All right, just going to check my answer before I stop the video. Oh, so hard to lift the book up. Okay, beautiful. All right, girls, see you later.